nc0 x. Look, you always take difference of these two terms, and that is the power of x. N minus 0 and y is 0. Then you have nc1 x n minus 1 y1. Then you have nc2 x n minus 2 y2, plus so on, and there you go in an rth term. Remember rth term, I will come back to this in the later lesson, but just observe there will come some number r in the middle, ncr, that will be a n minus r and br, and then the last term which is known as the nth term, ncn, a n minus n and bn. Now observe this, I'll simplify this. You know that, remember, nc0 and ncn, they are always 1. Write it somewhere. NC, so this is 1. Xn minus 0, this will be xn plus nc1 xn minus 1 y plus nc2 xn minus 2 y2, plus so on ncr a n minus r br, and plus so on. ncn is 1, this will become a naught is 1, and bn is left. This is known as the binomial theorem. Now the purpose behind the binomial theorem is just to find any expansion given where the two terms are added and there is expansion, unlike square and cube and 4 where you can easily solve them, but 7, 8, 15, 50, 100 or whatever, you can expand anything using the binomial theorem. So I will just do a little example for you guys on the basis of this theorem. You can see this in your additional mathematics book, the binomial expansion chapter, and you can see that the theorem is written in another form, that is 1 plus bn. This is not something different. I'll tell you how he has expanded it. Okay, if I go by the general rule, this will be nc naught 1 n b naught plus nc1 1 n minus 1 b1 plus nc2 1 n minus 2 b2, plus so on ncn 1 n minus n and bn. So look at this, any 1 raised to power any number is 1 again, so this will be 1 plus nc1 is nc1 b1 plus nc2 b2 plus nc3 b3, and plus so on ncn, that is 1, and bn. So this is another form. You can check this out as well. Whenever you have a 1 with a variable, you can always go for this. No need to apply the other form. But let me just tell you, this form and the previous one which I just wrote are not at all different. They are one and the same thing. So now for a little example that I'm going to solve. Say I have x square plus 3, and this is power 5, and he normally a question comes in a paper, find first 4 terms in the expansion. So this is the first 4 terms in the expansion. How come we find it? Look at this, 5c naught x5 minus 0, and what is b? 3 0, plus 5c1 x square 5 minus 1 3 1, plus 5c2 x square 5 minus 2 and 3 2, and plus 5c3 x2, and this is 1 2 3 and 4. Yes, this is the 4th term, 5 minus 3 and 3 3. No need to go further, so I'll just simplify this term. The 5c naught is this will be x7, and plus 5c1 is 5 into 3 15 x8, plus 5c2 is 10 into this will be 3 square 9 into answer into 9. This will be 90x, this will be 3 2 6, and the first sorry, this one is 10, and then you have plus 5c3 this is 10 into 27 with 3 cube, this will be 270, and 5 minus 2, this is x4, plus so on. So this is the expansion of the first 4 terms. And the final thing in this lesson which I'm going to tell you, remember that in this term, remember first term is an, then you have nc1 an minus 1 b1 plus nc2 an minus 2 b2 plus so on ncr an minus r br plus so on bn. So remember that the first term, this is t1 where nc0 is there. So when your r is 0, you have first term. So let me just tell you, this is the first term, this is the second term, this is the third term, this is the r plus 1. This is the r plus 1 term, remember, because you see that there is an r and this is the nth term. So n plus first term, sorry. So I'll just give you a little layout that t r plus 1, the rth term formula is ncr a n minus r and br. Don't get confused why I've written the r plus 1 term, because you see that when this is 1, the value of r is the previous 0. When this is 2, what is r? 1. When this is 3, what is r? 2. When this is r plus 1, what is r? R. When this is n plus 1, and then we have n, ncn. So that this r plus 1 term is very important in finding coefficients, and I'll share this in the next video.